The Euler's method is a way to approximately solve differential equations in the form of function of x and y. It's basically like going on a walk and trying to figure out which direction to start heading first, which is basically your first derivative, and also figure out how many steps you take to reach your destination.
Using this as an example, we can see that function of x and y is the same as the first derivative, which means that we can use this to find the slope of the tangent line. Okay, now we're going to be plotting a graph. We're just going to put the initial points first for x0 and y0, and that will be our first derivative. Later on, we'll be adding another line in front, like a step forward, to be our second derivative for us to form an equation. And if you notice, this gradient or like a slope is the equation that we were given earlier. Now that we have our information, we can now put in an equation. So we're doing y1 minus y0 equals to m times x1 minus x0. And if you notice, x1 minus x0 is basically the step size. It's the distance that you took forward to find the next y value. So after rewriting the equation with the step size and the function, I'm now substituting the values to find my y1 and my y2. When you see y2, you notice there's another pattern going. You can see a pattern being formed now, where the y value will be always adding an extra 1. Same as well as the function x0 and y0, it will be added 1. Now we're writing the pattern that we see and simplifying the equation, and as an outcome you will get yn plus 1 equals yn plus h times f function xn and yn. So we have our columns, our x value, y value, our function, our equations. So we're just adding the initial values that was given from the question, 0 and 1. And then we're putting in the equation for x first, since we need to know where to stop. We're stopping at 1 since that's what we're looking for. We're looking for the approximate value of y when x equals to 1. So for the function, we're just putting in the equation as given, x over y squared, and substituting it accordingly to what we see. Now we're just following according to the formula that was given, that we had that we solved together just now. Now when we look at the current y value, we can see our final answer. Now we'll be doing error analysis on the question that we did together just now. We'll be solving the differential equation as per usual, like how we usually do it, by putting all the like terms on one side and integrating both sides. Now that we'll be solving for y, and once we receive y, we need to find c. So to find c, we'll be substituting y function 0 equals 1. This means that when x is equal to 0, y will be equal to 1. Once we find c, we'll form our particular equation, and then we'll use our new equation to sub in the values for y equals to 1 to find x. Now we are subtracting our y function 1 value and our y10 value, which is from the Excel sheet. As a result, you can see that the approximation error is a really small margin of a difference, which means it's quite accurate.
The Euler's method is really quite accurate based on our error analysis, since the values are so small. That will be it for today.